All right, happy Tuesday. We are going to continue with our learning here in Algebra 1, continuing with our conversation on factoring polynomials in lesson 15 specifically. So if you've been present either in class or watching the videos for lessons specifically 5, 11, and 14, 14 most importantly, we kind of saw how to factor things by looking for GCFs and using that X table to figure out how to factor those. And that's where we're going to continue our journey through today. But first, as always, let's do our announcements. Okay. New Edpuzzle was posted today. You don't have to complete it right now, okay? I really want to focus on getting caught up with material that you haven't finished. So if you haven't done any of the old Edpuzzles, any of the old assignments, that is your priority at this moment, all right? The new Edpuzzle is really starting to integrate, meaning work together with where we've been on factoring and the zero product property, and then combining the two concepts to solve for seemingly more difficult equations. And I use that word seemingly purposely because once we realize how to factor and how to solve the zero product property, lesson 11, we can really combine the two and make solving equations actually a lot more fluid. But old Edpuzzles are still able to be revisited and completed. Old assignments, never hesitate to turn them in. This is kind of my official, I've been holding off on saying this out loud. This is kind of my official unveiling of this announcement. Although there are due dates for assignments, I will not mark you late if you get them into me before basically June 2nd or June 3rd, okay, the end of the school year. Now, the point of this is to really encourage you all to do the assignments and finish on a strong note rather than get nervous or occupied with following due dates, okay? I know you got a lot going on in your lives, heavy transition in school, specifically in math classes, and then you got a bunch of other classes too. So I really want to focus on getting the content and the work done rather than trying to speed through it just for the sake of meeting a due date. So long story short, you get an assignment done, you get it turned into me before June 2nd or June 3rd, you'll get full credit for it, okay? As long as you actually do it. So go back and do all the assignments you haven't done before moving forward and doing the new ones. All right. Remote learning agenda, RLQs, keep using them. Notice that those things are posted basically every single post I put on the classroom, okay? Because of the way the stream is set up, I don't really have control over how the stuff is posted other than the newest post is up top. So that's why I try to include these RLQs in the remote learning agenda every single post. And the remote learning agenda is this thing right here. I mentioned it pretty much on every single session. So if you've been in the last few classes or classes basically for the last month, you've probably seen this thing a ton. But this is the remote learning agenda. Notice everything that we've done. I have these little check marks next to it. So we've finished up through 5.1. Today is 5.5. Happy Cinco de Mayo. And that's why we're doing lesson 15 today. Notice there's some Edpuzzles that can relate to it. Focus on those before moving ahead. Lesson 15 textbook assignment, we'll probably get a decent amount of that done on Thursday, okay? So if you can tune in on Thursday, after we introduce the concept today, we'll try to get as much of that assignment done together in class. Long story short is, the reason why I bring this up, other than to reiterate that it's there for your knowledge and for your pacing, is to really talk about the final, and that's going to be done in a form of a project. So we're not going to have the classic like 20 to 30 question test. No way, not feasible or doable in this current situation. So what we're going to do is we're going to have a quadratics final, basically focusing on a project. We'll talk more about this around the mid to late 20s of this month. So kind of notice in this range down here, the 26th, 28th, and 29th. We'll talk more about it, but that's going to be your final, and it'll be due probably on the 2nd or 3rd. I just wanted to give you a little heads up on that final process, just so you can kind of see where we're coming from and be prepared for a project final, not a test final. Hopefully, I think that's going to kind of follow in tune with what we were doing a lot this semester, which we were doing different forms of assessment, aka testing through group testing and project-based learning as well. All right. Do I have any questions? Sorry, before I get off that, do I have any questions basically on anything that revolves or involves the agenda and also the assignments when they're due and the late, flexible late policy? Cool. If you have a question, y'all know you can unmute yourselves and ask, or just type it in the chat box. But without those questions, we're going to progress. Extra Zoom session, office hours. I saw a few of you on Friday. That made me very happy, brought a smile to my face. We have those every Friday at 10 a.m., okay, unless otherwise noted. So maybe if you
I
want to
was
join.
there just to let y'all know. Koi made it.
Koi did make it.
Yeah.
Yeah, and Andrew made it, and Tyler made it. So,
Oh, are you in this class?
Huh?
You in this class?
Yes.
he's in sixth period. Yeah.
I did not know that.
Yep.
Yes, sir.
Um, and it's good that Koi is now with us, as long as with all of y'all, because guess what? The final thing on this announcement at the bottom of the screen: T minus 4 weeks. We are in the final push. I'm going to mention it every single week. The countdown is on. 4 weeks until summer. That's excluding the finals week, but I'm not going to count that. So here we go. We are on the final run to summer. So what are we doing today? We're doubling down on our knowledge of factoring polynomials. We've been doing so with this X chart method, not because the variables are X's, but because that's what the chart that we've been working with has been kind of helping us do. It is the opposite of the distributive property that we talked about in lesson 5. And that's what we've been doing really for like the last week and a half. We're going to continue talking about it today. So without any further ado, let's turn our books, our notes to page 570, 571, 572. And we'll do that today. So big thing here in lesson 15, again, it's a reiteration, which means a repetition of the concepts that we talked about in lesson 14. And we're going to start off here on page 570, number 2. And in this situation, Juan is doing some math. So Juan has been given a couple problems. Juan's first problem is y equals x squared plus 8x plus 15, and his second problem is y equals 3x squared plus 15x minus 2. Now I want to stress that these are different, and actually let me highlight these in a little bit darker color here. These are different, specifically part B, because everything that we did last week was factoring things like part A. And they were like part A because our leading coefficient, our A value, if we think about it, flashback to our Edpuzzle and our knowledge of standard quadratic form, our number in front of the variable squared was 1. And that's all that we've done thus far. Now, the difference here in the one to the right is that our A value, our leading number, is not a 1. So I've been stressing this whole entire time that when we do these X charts, we do first times last, factors that add up to middle. And I've been doing it specifically for when we run into issues like part B here. So what we are actually about to see as we go through this on page 570, problem number 2, is that we are going to go through the steps, which actually Juan has, or they've shown Juan's steps right here. And we're going to talk about why he got him and then use that to kind of well-round our knowledge of factoring as a whole. So without any further ado, let's actually get to business here. Number 2, part A. Where did Juan get these multiples of 15? Well, he got that 15 from the following. He did the first number, which was 1. He did the last number, which was 15, and he said, all right, I need to find the multiples of 15, 1 times 15, that specifically add to 8. So what Juan did is he made a little space over here, and he found all these multiples of 15. He said 15 is the same thing as 1 times 15, and 15 is also the same thing as 3 times 5. Now, he chose specifically 3 times 5 because those add to that middle term. And if you haven't been present for the last few classes, the reason why we're trying to make it add to 8 is because that's what we're trying to expand here. So the next big step here in this problem is that Juan basically rewrote this 8x. The 8x became a 3x plus a 5x. So he took the two terms factors that he found and expanded that middle term. Well, what we talked about in previous classes was we can't find a GCF from any of these terms. None of these things have something in common, so we can't factor it out. We can't use a tactic called grouping because we have an uneven and odd number of terms. There's only 3 of them, term 1, term 2, term 3. So the whole process of this X chart that we see Juan executing right here in the box is basically to get to where we're at now. And that's to make, let me change up my colors here, 2 groups of 2. So he expanded that 8x into 3x and 5x, so that way we had a group of 2 and then a group of 2. And then would someone be so kind as to tell me, basically answer this last kind of blurb here, how did we get from here following the arrow? What step is basically being executed in this blue step? x squared plus 3x becomes x times x plus 3, and 5x plus 15 became 5 times x plus 3. Anyone know, basically, in your own
Distribution.
words, what was done?
Distribution.
Yeah, it is the distribution. It's actually the opposite of distribution, but distribution still nonetheless, like, because if we did distribute, boom, boom, that would actually be working in the opposite form, going upwards rather than downwards. So I love the idea of distribution and the answer distribution. But
Oh,
what,
you break.
huh?
Wait, what? How? Oh yeah. Oh, never mind. I see it.
It's good. It's good. It starts with an F. It's the F word, the math F word. Yeah, Sarah, good call. What did Juan do? He factored. He factored each group individually. He took the GCF, the greatest common factor, out of both. Juan realized that you could take an X out of both x squared and 3x, leaving you with x plus 3. And then Juan figured out that the GCF of his second group, I'm going to try to color coordinate this here so we see that they're the same, the GCF of both 5x and 15 was 5. So he took the 5 out of 5x, notice it's just x now, and he divided 15 by 5, and he got 3. So what did Juan do? He factored, he found the GCF, and factored it out. And keep in mind, GCF is just an acronym for greatest common factor. Cool. So that was kind of where we've been over the last week, is taking something that has 3 terms, expanding the middle based off the factors of the first and the last, what I sometimes call like the Oreo or the sandwich, using the bread to get to the meat. We used the breads, the outsides, to get to that middle 8. We expanded it, and then we factored each group individually. For those of us that were there on Friday, basically that was me saying we focused our attention on a smaller area, so that way we could try to find factors of 2 things rather than 4 things. Cool. Now, the big difference between A and B, other than the fact that it has different numbers, is that we don't have a leading coefficient, a number in front of 1, but that doesn't change the game at all. Okay, we still use the same steps. When we were working on this together last week, we set up this X chart. And I said, all right, we fill in the top, the bottom, and the sides. Okay, now they didn't put an X chart on this paper, but we can still use this to our advantage. Does anyone remember basically what we used to fill in the top of the X chart?
You multiply the first by the last.
Yes, Andrew, good call, man. The first number, 3, times the last number, which you notice I put that minus sign in there because it's a -2. So Andrew's right. The top becomes 3 times -2, and we know the product of 3 and -2 to give us a -6. Sweet, man. Okay, what about this middle down here? Or that bottom, sorry. Probably actually kind of just gave it away. Yeah, it's from the middle term. So there we go. That's why I said middle. So we multiplied to get the orange up top. We took these 2 orange terms, multiplied them, and then we just brought the middle term on down. Boom. Now the last step was to factor that -6. And that's what we're going to do right over here. We say, all right, how do I get -6? I could either do, one factor would be 1 times -6. There's many factors. You could do -1 times 6. You could do 2 times -3. You could do 3 times -2. Yada, yada, yada. All of those make factors, but why did they specifically choose these ones? Because that -1 and the 6 are the values that add up to the middle term. So what we talked about last week in lesson 14 was, as Andrew said, we make the top of the X by first times last, and then we find the factors of that number that add up to the middle. And sure enough, the factors of -6 that add up to +5 are -1 plus 6. So then what did we do? Or what did Juan do here? He rewrote that 5x as a sum of those numbers. And then it's off to the races. Here we go, finishing up. From here we group, 2 groups of 2. Notice my grouping symbol, my parentheses, red right there. And then, as Sarah said on the last one, what we did to get down here is we factored out the GCF. That X is the GCF of the first group. Notice they both legit have an X in it. Okay, This 2 right here, that's the GCF of my second group. Meaning what can I divide both 6x and -2 by? You can divide it by 2. And we specifically do so to create, as I struggle to get my highlighter, common parentheses. So again, once again, how did we get from there to there? We found the GCF and removed it. I'm just going to copy and paste. That's where we left off last week. The only difference between this lesson and that lesson is, like in part B, we now have polynomials that don't have a 1 in front, but it doesn't change the steps. And that's kind of why, if you've been present, either watching or present in class, these videos, that's why I've always been saying multiply first times last, even though all the ones we did last week were just 1. So that kind of seemed like an unnecessary step then. I was basically trying to set us up for when it get harder. So then basically is, what's Juan's final equation? Notice here in number 3, basically what they did is they said, all right, let's just take where we're at here and let's finish this problem. So can anyone take a guess as to what the answer for 3A would be? Francis, you're already on it. Good job, dude. He said, all right, you take the GCFs. So this is the final step, and this is what it says. When you have a situation and your parentheses are identical, as you notice they are, this is that distributive property that I think it was you, Coy, that said, right? The distributive property, which allows us to deal with GCFs, basically is now used to a T here. And it says, hey, since both x and +5, x and +5, so I'm putting them, if I'm saying and, I'm putting them next to each other, right? X and +5 are being multiplied by the same thing. The distributive property allows me to write it shorter by just stacking the x and the 5 next to each other, getting our factored form. Now, if I turned back around and did that FOIL process, I'd bet any single piece of money I'll ever earn that we'll get right back to where we started. Y equals x squared plus 8x plus 15. Sweet. Let's see if Francis gave us the answer to 3A. Anyone think they know the answer to 3B? Use different colors here.
Yes.
What do you got?
X plus 2 times 3x minus 1.
Right on. Y equals x plus 2 times 3x minus 1. Let's go Christmas colors here, red and green. And here's how we got that answer. Ready? Since both x and +2, shown in red, are being multiplied by the very same common parentheses, 3x minus 1, distributive property says we can combine that x and that +2 and multiply it by that very common thing, 3x plus 1. Sweet. That's it. That's really all the lesson that we did last week. So if you crushed this last week and you're like, oh my gosh, we're doing the same thing. Yeah, we are doing the same thing, because this is probably, in my experience as an Algebra 1 teacher, sometimes considered the hardest thing in all of this class. So that's why we're spending literally 2 weeks doing this. So hopefully we're starting to kind of grasp the concept behind it. Now let's move on to the next page, unless anyone needs me to slow it down and keep it on this page on problem 3 for about 10 more seconds. Speak now or forever hold your peace. I'll be moving down to problem number 5, if not. Sorry about the notifications. Cruising. Okay. Here we go. Factoring. Same idea, different problems, obviously. Part number 5, and this is on page 571. This is like one that we did last week, meaning leading coefficient, a value, first number is 1. So first thing we always look for is GCF. Is there something that all three common, that C and GCF have in common? No. Can't take something out of all 3. The first 2 have an X, but the last one does not. So GCF doesn't work right now. I can't make equal groups because notice that one has 2 terms. This one only has 1 term. And no matter how I group 3 things, it's going to be unequal. So what we do is we set up our beloved X chart. Here we go. X chart, again, nothing to do with the fact that we have the variable X in here. It's just a way of thinking about it. Andrew said that we fill the top by doing the first number times the last number. Hey, boom, look at that. A times C, first number times last number. What's A times C in this case? 1 times 10, which is 10. What are we filling in the bottom here? That middle term. Got to get through the bread to get to the meat. So we get through the bread, the outsides, to get to the middle, the meat there. And that is a 7. So now we're trying to find the factors of 10 that add up to 7. Anyone have a hunch what factors of 10 could be that add up to 7? Yes, Francis, good call, man. 2 and 5. 2 times 5 is 10. Money, they're factors. And 2 plus 5 are 7. Now, what's the whole point of this? It's a great question you might be asking yourself. And the whole point of this is basically to take this polynomial, this 3-term thing, and now make it into 4 terms, meaning to expand this 7x into a 2x and a 5x. Trying to keep it red there so we can see where I got those numbers from. Because now the final steps are as follows. Once we get to here, once now that we have 4 terms, 1, 2, 3, 4 separate terms, no point in combining the like terms because that takes us right back to where we started. So here's what we do. We make a group with a grouping symbol, parenthesis. We make a second group with a grouping symbol, parenthesis, and we're off and running. Now I look for GCFs. GCFs, are there any? Of course there are. What can I take out of my first group? Anyone know?
You can take out an x.
No doubt, because look at that. Andrew's right. There's an x in both. There's an x here and an x there. So what we did last week is we realized that if you have an x squared and you take out by factoring, you're dividing. That's the same thing as x squared is the same thing. Our numerator, x squared, is the same thing as x times x. Thus, when we simplify that fraction, all we have left on the inside is in x. And if you legitimately, looking at that red 2x, if you legitimately take out the x, all you're left with is 2. Cool. I know I'm going through this in long fashion, so we'll move through it a little bit quicker once we get through this one. What can I take out of both? What GCF can I take out of both of these terms? And here's
5.
yeah, good call, Andrew. Here's a shortcut that we talked about last week, by the way, is even if you struggle to figure out what that GCF is 5, here's the shortcut. To make this work, the parentheses have to be the same. So once I get to here, I just copy and paste, rewrite that parenthesis to the right. And then it's like, okay, cool. How can I make a 5x into an x? I got to take out the 5. And sure enough, it holds true because if you divide 10 by 5, what do you get? 2. So Andrew was totally on it and right. 5 is our GCF, which takes us to the final step. As I'm getting out of breath here, I'm going to do more cardio, I guess. I combine my GCFs, x and 5, boom, boom, my green things, and I multiply it by that same common parentheses, x plus 2. We call the day on that number. Zaid, what are you doing, man? Zaid, put it away. I don't need you doing pyrotechnics on the video right now. All right, cool. So now we're on to number 6. Again, the only difference between numbers 5 and number 6 are that the numbers look different, but the difference is that the main difference in terms of difficulty is the A value is a different value. So everything that we did on number 5 was predicated around last week because that first number was a 1, now it's a 4. So rapid fire, here we go. A times C, ready? A times C gives us 4 times 1 or 4. We got to find the factors of 4 that add up to what? 5. So again, what I'm doing right now, y'all, is I'm basically just doing this X chart in like super speed, okay? Here's the X chart, and I'm trying to find greens, the factors of 4 that add up to 5. Anyone know factors of 4 that add up to 5? They're pretty easy. They're actually literally right in front of your face. Yeah,
4.
Apprentice, 4. The numbers that we actually use to get there, and 1. Cool. So those are the factors of 4 that add up to 5. So now we cruise, and we cruise with style and grace because we're coming down here. We rewrite our first term, didn't need to expand that. We rewrite our last term, Didn't need to expand that. All we had to do here, y'all, was expand that middle to make two terms that added up to it that were factors of the outsides. Let me get all these extra arrows out of the way. And now we're rolling. What do I do from here? Can anyone tell me a word what I should do from this point? Zaid, you got it? Yeah.
I think combine.
You could combine them, but if we combine them, we'll be right back to where we started. So I like the thought process.
That's not what I meant.
Starts with a G. Ends in grouping.
Grouping.
Oh, dude, there it is. We group it. Look at that. Now that we have uncombined it, we have the ability to make two equal groups, two groups of two. Cool. So we are now in the group situation. Thanks, Zaid, for that. And now from here, what do we do? Yeah, good call, Francis. We look for that GCF of each group. Can anyone identify what I could take out of the first group? What is the GCF of the first group? Let me change my color to purple here.
4x.
Yeah, you could take a 4 out of both. Boom, boom. And you could take an X out of both. Sweet. Because look, they both have a 4 and they both have an X. So you could take numbers and variables out of things. So that's our GCF. And when you take a 4x out of 4x squared, well, the 4 is gone and one of the x's is gone, which leaves me with just an x. And what happens when you divide anything like 4x by itself? What do you get? We are on, and you're right, Sarah, we do get a 1 when we factor out the GCF. We are on number 6 on page 571, y'all. Just heads up. Page 6, page 571, number 6. All right. Cool. So what can I take out of these two terms over here? By the way, I forgot my x. What can I take out of both 1x and 1, knowing that my goal is to have that same x plus 1? It's quite the stuffed animal type thing you got there. What could I take out of both 1x and 1? Well, the 1. Kind of seems weird, but yeah, we could take a 1 out, no doubt. So now our parentheses are the same, distributive property, but in reverse says, hey, let's combine our GCFs, aptly written in purple for ease of seeing, 4x and 1, and then we combine it with that common parenthesis x plus 1, and we have ourselves a wonderfully factored form. That's it. That's all, folks. That's basically the whole lesson. But we're going to spend a little bit more time either doing some practice problems if need be, or doing some homework problems, because we will hopefully, by the time that this week is done, Thursday's lesson is done, be done with 14 and 15 as a class, okay? All right, do we have any questions on the problems that we've done thus far, which were 2, 3, 5, and 6?
It's kind of off topic, Mr. B.
Yeah.
But, I just want to confirm because I'm a little confused. So we're not having a final?
You will not have a test final, you will have a project.
Is it going to be part of your project or it's just like a self-project?
To be determined. I think solo project.
Okay.
But well, I'm really actually going to narrow in on that this week, and then I'll disseminate, meaning give you that information next week. It's a good question, man. Also, while I have you, Zaid, I went to Trader Joe's on Sunday and half expected to run into you there.
Oh, I told my mom just to go, just to get a little, like, just something little, just so I go to Trader Joe's. And she's like, we have enough food here at the house. I just thought we're missing something. But she wouldn't let me go.
Sorry, man. Maybe this next Sunday, although this next Sunday is Mother's Day, so don't make your mom go to Trader Joe's on Mother's Day. That's probably in bad form. All right, off we go. Number 10, it is our final one, which is why the word reflection is around on it. So we're going to reflect on all the beauty that we've done over the last week and today. Number 10, Melissa said you don't have to factor out a GCF right away. Here's her work shown. And basically what this is saying is, if we look at this right from the jump, there actually is a GCF right away. Can anyone tell me what that GCF is in the green ovalish thing. Green ellipse.
That would be 2.
Yes, sir, Andrew. So right away, and some of y'all saw this on the Ed puzzle, but right away, as Andrew said, we have a GCF here. We could divide every term by 2. So right from the start, we could literally rewrite this problem as the following. Taking a 2 out of everything, we could rewrite it like such, and then we could focus our attention on factoring that behemoth, okay? Which, you know what, just for the sake of it, we might do later. But since the reflection says, no, let's not do that, we don't have to do it right away. If we're just kind of getting comfortable with what the first times the last factors added to the middle mean, we're going to do it as we see here. So Melissa got to 16 by doing the following. She said, hey, where'd I get that 16 from? A times C, first times last, factors that add up to middle. So she took 2 times 8, she multiplied them, and got 16. And then she found the factors of 16 that specifically added up to what number? 8. There we go. So the factors of A times C, first times last, that add up to middle, she then replaces them. So now we have a little kind of awkward flow chart going on. So we're here, basically where the purple arrow led us to now. Multiply the first times the last, the bread, the Oreos, the cookies on the Oreo to get to the creamy, delicious middle of 8x, and then we took the Oreo and expanded it, okay? If you're one of those people who like to eat Oreos like that. Now, what did Melissa do from here? Grouped, cool. What is this 2x in relation to 2x squared and 4x? That's the GCF, so she factored out the GCF. What's the GCF of the second group? What can I divide both 4x and 8 by? 4. And look at this glorious thing that we just found, that are both of our parentheses currently being highlighted in green are what? The same. So then she could take her 2 GCFs in red, oops, wrong one, and combine them, stack them with, in multiplication, the x plus 2. Now the final question I had to ask is basically, how did we get from here to there? If we're all cool with this, and this is the process that we got to, I'm going to make an argument that the bottom or the tail end of the orange arrow here is technically the most factored form. What is the one thing that Melissa did to get from the box down to the 3 underlined final answer? We don't have a hunch. Yeah, if you got to take off early, that's totally fine. I appreciate you being here. I'll give you a hint. One, I did commutative property, just moved the red and the green around. So there's that, switched them. But what's the difference between this red and that big red highlight?
You factor the red parenthesis.
Factor the red parenthesis out with the GCF. That you're 100% right, Coy, and Andrew led us to the beginning. So if we had factored out the GCF first, and then went about factoring this behemoth right here, we would have gotten the parentheses x plus 2 times x plus 2. Trust me on that one. We could do it with the next tactic. But either way, whether we factor out the GCF first or at the very end, the results are the same. So what's the factors of factoring? What's the advantages of factoring out the GCF right away? It makes the trinomial easier numbers. That's really the only advantage, but you could still totally do it without that. All right, y'all. We have 7 minutes left technically in this class. I'm going to do the first problem of our homework, and then we're going to call it for today, okay? Get you all out of here a little bit early. Does anyone need me to leave it on this page on number 10 before I continue moving forward?
Nope.
Sweet, okay. Let's cruise on down to page 575. See, what homework do we have? Number 1. Okay, number 1. That's easy, right in front of me. So we want to factor this by effectively using the X tactic. And notice that this box over here on the right is just like a different way of representing the same information as the X tactic, right? So if you're really comfortable with the X tactic, let's use that and basically color coordinate what we're looking for here. Okay. Top part, green, is a byproduct of A times C, first times last. What is your A value? 1. What's your C value? 24. So we're looking for the factors of 24 that add up to 14. Anyone think they know the factors of 24 that add up to 14? Sarah.
12 and 2.
Yeah, Sarah and Andrew, I think that was you, right? Crushing it with 12 and 2. Nice, because 2 times 12 is 24, and 2 plus 12 does give us 14. Nice. The whole purpose of that was not to be awesome at factoring numbers, but rather to expand, and let me use just green here to stick with the colors, this polynomial. So basically my question now is the following. What goes in the blank here? Anyone know? I'm rewriting this 14x.
Is it the factor?
Yeah, it is the factors. So that's the 2x and the 12x. Great call, Zaid. So now we take it out. What's the whole purpose of this? Can someone reiterate that information to me? Why rewrite something that's 3 terms and make it bigger and seemingly like make this more complicated than the start? What's the point of that?
So you can put it into 2 different pieces.
Yeah, to put it into 2 different pieces. When you have a big group of people, it's hard to find something that hard to find something that everyone has in common. But if you can break it down into smaller groups like y'all do with your friends, it's much easier to find commonalities, things that are interesting to you both or all of y'all. That's really what we're doing on a number sense. We took something and expanded it momentarily to then narrow our focus in on 2 terms, one at a time. So now the very last thing we got to do is find those GCFs. What can I take out of my first group? What can I take out of both an x squared and a 2x?
X.
X, boom, boom. Leaving us with, you take an x out of an x squared, you get a regular x. You take the x out of the 2x, you just get 2. Nice. Here's the shortcut. Once I know my first parenthesis, if this is going to work, it's got to be my second parenthesis. So here's how I always like to think about it. What do I got to take out of 12x to make it an x? Well,
12.
the 12, yeah, the 12's got to go. And sure enough, if you divide 24, remember factoring is multiplying, so theoretically moving backwards, taking it out is dividing. 24 divided by 12 is what? 2, the money that we were looking for. And the final step is once you got your GCFs shown in red, x and positive 12, combine them. This is kind of the distributive property in a non-traditional way that we don't learn it like this normally because it's more advanced distributive property, but since both x and 12 are being multiplied by x plus 2, we can combine that x and the 12, stack it next to the x plus 2, and call it factored. Andrew, Francis, great job with your answers there. Good job. X plus 2 times x plus 12. Does it have to be x plus 2 in front? No. Notice Andrew and Francis's answers have these 2 switched. We know that's all gravy, all good, because the commutative property says the order in which we multiply does not change our answer. And it looks like Zaid is having a strobe light party to celebrate a correct answer. So on that note, y'all, if you have any questions, let them fly right now. If not, have a great rest of your day, a fantastic Thursday, okay? And I'll see you on, fantastic Wednesday, and then I'll see you on Thursday.
Hey, Mr. B, guess what?
What?
My little brother made me breakfast.
Your little brother made you breakfast?
Yeah.
That's a nice treat. What do he make you?
How he sees over the stove. He's like, small.
Hey, well, that's awesome. Did he make you pancakes or something?
No, he made me eggs and bacon and sausage.
Zay, you're gonna burn your house down.
Thanks, Jeff. You too.
I know.
Sounds like a pretty good breakfast, man. Thanks, Mia. Have a good day. I'm gonna stop recording.